Have you ever stopped to wonder how it all works? You tap a button and a message zips halfway around the world in a blink. Or how your TV just knows what movie you want to stream from the internet. It really does feel like magic, doesn't it? But it's not. It's all thanks to the power of computer networking. So let's dive in and take a look at the invisible architecture that connects our entire digital world. Okay, let's start with something you probably do every single day. You've got your phone in your pocket, music playing on your wireless earbuds. There are no wires, right? But they're talking to each other perfectly. How? Well, that simple, everyday connection, that's our very first step into understanding what networking is all about.
To really get a handle on this, we're going to start small, really small. Our journey begins with the first, tiniest circle of connection, the network that exists right there around you, inside your own personal bubble.
And that little bubble? That's what we call a personal area network, or a PAN for short. It's a network designed for just one person's space. I mean, think about Bluetooth. The whole point was to finally get rid of that jungle of cables connecting your computer to your mouse or keyboard. With a PAN, your devices just connect. That link between your phone and your earbuds? Yep, that's a perfect example of a PAN in action.
You know, no matter how big or complicated a network gets, it's all built from two simple, basic parts. First, you've got nodes. That's just a fancy word for the devices themselves. Your phone, your laptop, you name it. And second, you've got links. Those are the connections between them, whether it's an invisible Bluetooth signal or an old-school physical cable. Nodes and links. That's it. That's the foundation for everything we're going to talk about.
All right, so we've got our building blocks. Let's see what happens when we use them to build something a little bigger. We're zooming out from our personal bubble to the size of an entire house or maybe an office.
And this is what we call a local area network, or LAN. If you have Wi-Fi at home, congratulations, you've got a LAN. And its real superpower is sharing. Instead of every single computer needing its own printer or its own internet line, a LAN lets everybody in the building share the same stuff. It's way more efficient, and it's pretty much the backbone of how most homes and offices get online today. So you've got all these devices in one building. How does it not turn into total chaos? Well, the earliest networks were kind of like a crowded room where everyone was just shouting at once. Today, things are a whole lot smarter. Most modern LANs use a central hub, a little box called a switch. You can think of it as the digital traffic cop for your local network. So here's how that traffic cop works. Let's say your laptop needs to print something. The switch is smart. It doesn't just blast that print job out to every device on the network. No, it knows exactly which physical port the printer is plugged into, and it sends the data only there. Your TV wants to stream a movie? The switch sends that request straight to the router, and nowhere else. It basically creates a private, direct line for every conversation. This makes the whole network faster, way more efficient, and a lot more secure. Okay, so we've connected the devices in our body, and we've connected the devices in our building. What's next? You guessed it. We're zooming out one more time, moving from the local level to the truly global stage.
And that brings us to the Wide Area Network, or WAN. The biggest difference here is just the scale. A LAN connects all your stuff in one place. A WAN connects all those different LANs together, across cities, across countries, across oceans. So your home Wi-Fi is your LAN. The internet, that's the ultimate WAN, linking millions upon millions of LANs all over the globe.
And this quote here really nails it. The internet isn't some single magical cloud. It's actually a massive, sprawling web of thousands of smaller networks that have all just agreed to speak the same digital language.
Which leads to the million-dollar question, right? If the internet is just this giant patchwork quilt of different networks, how on earth does an email you send from New York find its way to a server in Tokyo without just getting completely lost?
Well, the answer is this brilliant process called packet switching. So your message, whether it's an email or just 1 second of a movie, gets chopped up in these tiny numbered pieces called packets. Each and every packet gets the final destination address slapped on it, just like a postcard. Then, special devices called routers act like post offices, looking at the address and forwarding each packet along its journey, one hop at a time. Then, at the other end, the computer just uses the numbers on the packets to put all the postcards back together in the right order. It's amazing.
But think about this for a second. For any of that to actually work, for routers to read addresses, for computers to reassemble packets, every single device from every company all over the world has to agree on a common set of rules. They need some rules for the road.
In the world of networking, these rules are called protocols. That's all a protocol is, a shared language. It's just an agreement on how to format a message, how to say, "I got your message," and what to do if a message gets lost.
Without protocols, the internet would just be pure chaos.
The main rulebook for the internet is called TCP/IP, and it's organized in layers, which makes it easier to manage. You can think of it like sending a package. The application layer is like writing the letter itself. It's the stuff you actually see, like a website using HTTP. The transport layer is like putting that letter in a numbered series of sturdy boxes, making sure it all gets there safely. And finally, the network layer is the postal service itself, reading the address on each box and figuring out the best route to get it to its destination.
All right, we've covered a lot of ground. So now let's pull all of these pieces together and take a look at the big picture of this invisible, connected world we live in. Your entire digital life really exists inside these nested circles. It starts with the personal area network, right there on your body. That PAN then connects to the local area network in your home or your office. And that LAN, in turn, connects to the global wide area network of the internet, linking you to basically everything and everyone else.
And the amount of data flowing through these circles is just mind-boggling. To put it in perspective, a single standard digital phone call needs 64,000 bits of data to move through the network every second. Now try to imagine that multiplied by billions of video streams, messages, and bank transfers all happening at this very moment. It's a non-stop global ocean of data, all guided by these surprisingly simple rules.
It's an absolutely incredible system that has changed our world forever. And it leaves us with one final thought to chew on. As we continue to connect everything from our cars to our coffee makers to the internet, what new, maybe even smaller or more specialized circles of connection are we going to invent next? Because the story of how we connect is definitely far from over.